Welcome to homework.
The probability that a person is a smoker from the table would be equal to 0.4 plus 0.15 at column A, which is 0.55. The probability that a person is female is the probability of B, which if you add row B is 0.4 plus 0.35, which is 0.75. The probability that the person is a female smoker, that's the probability of A and B, and that would just be where the row B and column A intersect, which is 0.4. The probability that a person is either a smoker or female or both would be the probability of A plus the probability of B minus the probability of A and B, which would be 0.55 plus 0.75 minus 0.40, which is 0.90. The probability that a person is a smoker given that she's female is the probability of A and B out of the probability of A, which is 0.4 out of 0.55, which is 8 out of 11. Oh, I did that wrong. 0.75. Which is 8 out of 15. F is the probability that she's female given that she smokes, so that's the probability of B given A, and that would be the probability of A and B out of the probability of B, and this is the 0.4 out of 0.55, which is 8 out of 11. Smoking and gender of a person are not mutually exclusive events. And that's because the probability of A and B is not equal to 0. To check for independence, we compare the joint probability, the probability of A and B, with the product of the marginal probabilities, the probability of A and the probability of B. So the probability of A and B is 0.4, but the probability of A times the probability of B is 0.55 times 0.75, which is 0.4125. And since these are not the same, they are dependent events.